All right, folks, today we are talking about Hess's law. Hess's law is yet another way of solving for the delta H of a reaction, okay? So instead of using a thermochemical equation like we learned way up here, like these guys, okay? So instead of just using a basic thermochemical equation using some mass and some energy associated with it, instead, what we're going to be talking about is piecing the reaction together from known steps and then adding the delta H up from those various steps. Okay, so let's walk it through. So if a reaction is carried out in a series of steps, the delta H of the reaction is the sum of the delta H's from each step. Okay, so here are some rules that we need to follow. If a reaction is reversed, the sign on the delta H is flipped. You guys saw that in your homework the other day. So if a reaction is reversed, we saw if the sign was positive, it becomes negative, and vice versa. Also, if a reaction is doubled, the delta H is doubled. Okay, and that goes for like if the reaction is halved, then the delta H is halved, and so on. Okay, so basically whatever you do to the reaction, you have to do that to the delta H as well. So let's take a look at an example here. So here is an overall reaction that we want to know what the delta H is for this overall reaction. What we're going to do is we're going to build this reaction from these steps, okay? I want you to treat these as puzzle pieces. We are going to put these steps together in a way that they cross out and they overall build this reaction here, okay? So this is the way I like to do it. Again, my goal is to build this reaction from these puzzle pieces. So what I like to do is start and basically look at what each step offers me. So let's see, this first step here, I see that I have a lone carbon and I do need a lone carbon. And that's actually the only thing that's super helpful. I do need some O2, but I need half of an O2, and that's a full O2, and I don't need any CO2. But if I use any part of the step, I have to use the whole step. So this is what I'm going to do. I'm just going to copy it down as it is. I've got C solid plus O2 turning into CO2. And that makes my delta H negative 395.5 kilojoules. And this is what I'm going to do. I'm gonna check off that I got my carbon covered. Okay. Next thing I'm going to look at is my next reaction. If you guys look at this reaction here, the carbon monoxide is a reactant, but in the one I want, it's a product. So what I'm going to do is I'm going to flip this in the other direction. So I'm going to make this the reactant, and then I'm going to make these guys the product. So I'm just going to reverse the reaction. So I'm going to copy it down reversed. So when I copy it down reversed, I get CO2 gas turning into carbon monoxide gas plus 1/2 O2. Oop, I need O2 there. Okay, and because I reversed it, the sign on the delta H is going to be reversed. So now instead of negative 283, it's going to be positive 283. Okay, and what that did for me is now I have my carbon monoxide as a reactant. And let's take a look at what's left over when I combine these, okay? So now what I'm going to do is basically add these together, crossing out things that are on opposite sides of the arrow. So what I mean by that, if you guys notice, CO2 is a reactant. I'm sorry, it's a product here, but it's a reactant here. So because they're on opposite sides of the arrow, they cross out. Okay, so the CO2 is going to cross out. It doesn't look like, let's see, the carbon does not cross out. The carbon monoxide does not cross out. However, I have half an O2 on the product side and a full O2 on the reactant side. So that means half of an O2 is going to cross out. And if I cross out 1/2, I have 1/2 left over. So now let's look at what's left when both of these are combined. So I'm going to copy down everything that's left on the reactant side. And then copy everything left on the product side. And I have that good. And would you look at that? This matches this. So now I have all the parts covered that I needed. Okay. Now to get the overall delta H, what I'm going to do is add these guys up. Okay. So negative 395.5 plus 283 is going to give me an overall delta H for this reaction of negative 112.5 kilojoules. So now I know that the delta H of this reaction is negative 112.5 kilojoules. Okay, so that is how you do Hess's law. The next one, if you guys want to pause and try to do this one on your own, again, we're trying to build this overall reaction using these guys as the steps. This one is definitely harder than the previous one. So if you want to just watch me walk through it, that's another option. It's up to you. So if you want to pause and try it out, go ahead. Otherwise, here comes the answer. So let's see. Let's see. So the first thing, I've got two B's and then I have two B's here. So I definitely know I'm going to need to keep this reaction as written. So I'm going to go ahead and copy that down. That's 3 halves O2 turning into B2O3 solid, and then the delta H for that -1. Okay, and so I know that this is covered. Next, let's see, what's helpful about this next thing? It looks like this is a product, but here it is as a reactant. So what I'm going to do for this reaction is I'm going to reverse it. Okay, so that I can have this guy on the product side. So reversing it, I'm going to have B2O3 solid plus 3H2O gas turning into B2H6 gas plus 3O2 gas. Okay, oh gosh, I'm running out of space here. So it's negative 2.035 kilojoules. Okay, so that was that step. And I now have this guy covered as a product. Next up, so in this one, do you guys notice I need 3 H2s? And here I only have 1 H2. So what I'm going to do for this step is I'm going to multiply this step by 3. So basically I'm going to do that. Okay. So I get 3 H2s out of it. So I'm going to do 3H2 gas plus, so this right here says 1/2 O2. So multiply it by 3, I'm going to have 3 halves O2. Yes. Turning into H2O, 3H2O. Liquid. Okay, and then because I multiplied this guy by 3 over here, I also have to multiply this guy by 3. Okay, so 3 times that is going to give us negative 858. Okay, let's take a pause and figure out what has worked so far. So we just did the 3H2 on the reactant side. So currently it looks like we might be done, but let's make sure that we know what we're doing. So let's cross out what crosses out so far. It looks like we've got this and this will cross out. And then this is left over, which is good because we want it left over. Here we have 3 halves plus 3 halves is 3. Okay, 3 halves plus 3 halves is 3, and look at that, we also have 3 O2 on this side. So this and this all cross out. And then let's see, we have 3 H2, that's good. Okay, here's a problem, guys, though. Do you guys notice we have 3 H2O gas on the reactant side and 3 H2O liquid on the product side? So that's no good. They don't cross out if they're in different phases. So that's where this last step comes in. we need to cross out 3H2O on the product side needs to be crossed out by 3H2O on the reactant side, and vice versa over here with the gas. So what I'm going to do with this guy is just multiply it by 3. Dun, 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 like that. Okay, and so what that's going to do is give me 3H2O liquid turning into 3H2O gas. And again, because I multiply it by 3, the delta H of that is going to be multiplied by 3. So it's going to be 132 kilojoules. Okay, so now that that's all figured out, take a look what that happens. Now we have 3H2O liquid and 3H2O liquid on opposite sides of the arrow, so they'll cross out. Okay, and then we also have 3H2O gas and 3H2O gas on opposite sides of the arrow, so they will cross out. So now let's figure it out. We've got everything left over. So on the reactant side, we had 2 B's and 3 H2s. And then on the product side, the only thing that's not crossed out is our 2B or B2H6 gas. So this overall reaction does match the one that we want, so we know we did it correctly. Last step is to add together all of the delta H's for the reaction. So this delta H is going to be 36 kilojoules. Okay, so now we know what the delta H of this reaction is. Okay, so that is Hess's law.